Let me show you what my Mageplot Jupyter notebook can do. First of all, the link to purchase it will be in the description of the video. You can purchase it from my itch page, and the most current version is V3. So there's a V1, V2, and V3. So when you purchase my Mageplot notebook, you're purchasing all three versions, but I suggest you use the V3 version. Let's go to it and see what it does. So first of all, you can build a 2D PCA chart on the basis of your dataset. So it can be a G25 dataset, it can be a Eurogenes K13 dataset, it can be any numerical dataset you have. It could be an FST table. So first thing you can do is you have to run this. You upload your CSV file. It has to be a CSV file, and it's gonna analyze it and give you a 2D chart, 2D PCA chart. Very interesting, right? But that's not the only thing it can do. The second thing it does is it can build a phylogenetic tree on the basis of your dataset. And you can actually set how many components you want to use principal components for the tree. Usually, there's a sweet balance between too much and too little. I previously used 2 in my video about the genetics of West Eurasians, but I noticed that it's better to use a little bit more, like 5. So let's try this again, and let's upload our dataset here. And we upload our dataset, and it's going to analyze it, and it's going to build us a phylogenetic tree. So you see, it builds a phylogenetic tree on the basis of that F2 and FST dataset, and we see that French cluster with Croatians, Spanish cluster with French and Croatians, Greeks cluster with Spanish and French and Croatians. You see that Russians cluster with Finns and Estonians, but Estonians and Finns are slightly closer. We see that Iranians cluster with Georgians, Lebanese cluster a little bit further. We see Tajiks cluster with Gujarati. We see that Punjabi are like a separate group all on their own. So it's very interesting. You can make a phylogenetic tree like that, and you can actually set how many principal components you use for your phylogenetic tree, which is pretty interesting. This next thing is you can generate Euclidean and Manhattan distance matrices for the populations. By the way, let me remind you, this can work on G25 datasets, Eurogenes K13 datasets, any numerical dataset you have, you can use my tool with. So let's try this. Let's try generating Euclidean and Manhattan distance matrices on the basis of our dataset. Let's upload it, and what do we see? We see a Euclidean distance matrix and we see a Manhattan distance matrix. They look pretty similar, don't they? Yeah, but it's very interesting. You can actually set up the custom colors for these matrices, but the only colors you can use are green, red, and blue. Let's close this. And the last thing you can do with my Jupyter notebook is you can identify divergent groups and model other groups as mixtures. This is very, very interesting, by the way. This essentially picks out anchor populations, or it picks out divergent populations, and then it tries to model the rest of the populations as a mixture of those divergent populations. And you can actually set a threshold for what percentage of populations you will consider as divergent. If you have a small data set, it's better to use a larger threshold, like something above 50. If you have a larger data set, it's actually better to use a lower threshold, something like below 30 or 20. This dataset is pretty small, so I'm using threshold 60. Let's try that. Let's upload our FST table. And after we upload our FST table, we see it identified divergent groups, which are Somalis, Ethiopian Jews, Saudis, Lebanese, Tajiks, Finnish, Punjabi, Gujarati, Tunisian, Estonian, Berber. And it models the rest of the groups as a mixture of those divergent groups. So we see that Russian is getting modeled as a mixture of Lebanese, Tajik, and Estonian. 80.87% Estonian, 12.35% Tajik, 6.78% Lebanese. We see that Croatian is getting modeled as a mixture of Estonian, Tajik, and Lebanese. We see that Greek is getting modeled as a mixture of Estonian, Lebanese, and Tajik. So basically, that is what it is. You pick out it picks out divergent groups, which are on the bottom, and it models the rest of the groups as a mixture of these divergent groups, which is very interesting. It can help you build a phylogenetic tree if you're trying to build a phylogenetic tree. It can help you with that, and it's actually very, very, very useful. I don't think there is any tool online that will do this for you. So this is definitely something that's very unique to my Mageplot tool, and this is probably the biggest reason you should buy it. So go to the description of the video. You will find the link to my Mageplot tool that I sell, and you can purchase it. Wait, what does it say V2? Let's upload that. Yeah, it says V3. So you purchase my V3 Mageplot tool, and you can try it. Try running your G25 datasets through it. It's very useful. You will not regret.